Recently, I decided to build a model airplane out of foam. This is what happened on the maiden flight. I bought this plane as a kit from a company called Flight Test. There's a link to the product in the description. The design is a twin-prop seaplane inspired by a 90s cartoon from my childhood called TaleSpin. The kit comes as a bunch of sheets of waterproof polystyrene foam. Flight Test sells boxes of these sheets, but I went ahead and purchased what they call a speed build kit, which just means they use their laser cutter to pre-cut all the pieces. This saves a huge amount of time. I followed a build video that Flight Test posted on their YouTube channel. They go over every step in great detail, so I would recommend watching that if you're going to build this plane. The first step was to build the wing. There is a rectangular spar that runs the entire length of the wing, which gives it great strength. I used an industrial hot glue gun to glue all the pieces of the plane together. You'll want to use a glue gun that can extrude a large amount of glue quickly. Your average craft glue gun probably won't work for this application. Here you see me cutting a bevel on the leading edge of the wing. This allowed me to bend the foam into a proper airfoil. Next, I aligned the two halves of the wing and taped them together. I used a ton of glue in all the joints to make sure the wing kept its shape. Next, I had to cut 2 slots in the wing where the 2 motors will go. After the wing was done, I went on to build the upper fuselage. I removed all the pieces I needed from the foam sheets. This part really demonstrates the advantage of the speed build kit. I can't imagine how long it would have taken to cut all of this by hand. Next, I slid the wing through the upper fuselage and centered it by measuring each side. I kept adjusting until both sides were equal length. Once I was happy with the placement, I glued the wing into place. The next pieces I worked on were the 2 nacelles. These are the long square tube structures that connect the motors to the rear of the plane where the rudders and elevator are. I did several test fits to make sure I got good alignment. I had to trim off small pieces of the nacelles to get them to fit just right. Before I could glue in the nacelles, I had to route the motors and the electric speed controllers, or ESCs, through the wing towards the fuselage. Once the motors were in place, I glued the nacelles in. Now it was time to work on the elevator. I had to cut a bevel in the foam to ensure full range of motion of the elevator. Next, I glued the 2 rudders onto the elevator. This kit allows you to use the rudders in a conventional way, but Flite Test recommends to leave them attached and just use differential thrust from the 2 motors to achieve movement in the yaw axis. When I was happy with the fit, I glued the elevator and rudders into place. Next, I needed to install the elevator control rod. The kit came with a coffee straw that I glued into place. I placed the control horn in the elevator, but didn't glue it in quite yet. I needed to measure and cut the right length of the control rod. I placed a 9-gram servo on the inside of the nacelle. I removed the sticker on the side and went over the surface with some sandpaper. This will help with adhesion when it comes time to glue it in. After the servo was installed, I attached the control rod and tested out the motion of the elevator. Next, I ran control wires for the 2 aileron servos through the wing and into the fuselage. Then I glued them into place. I did the same thing with the aileron control horns and control rods as I did before with the elevator. I centered the servos and carefully cut and bent the rod to the right length. Again, I cut a bevel into the foam to allow full range of motion for each aileron. The 2 aileron servos need to use the same channel on my receiver, and normally one would use a splitter or Y cable. I didn't have one on hand, so I made my own by splicing the 2 ends together. I tested the ailerons and elevator to make sure they were working properly. Next, I built the 2 motor mounts. The build video I was following didn't explain how to do this part, so I just guessed. I prepared to mount the motors by screwing on the bracket. These can be tricky because there's only one orientation where the holes line up. Next, I slid the motor mounts into the nacelles. Now it was time to build the lower fuselage. Because this is a seaplane, the lower fuselage has to act like the hull of a boat while it's on the water. Making sure this part is watertight is really important. Next, I assembled the tray that holds the battery. I made this acrylic piece to reinforce this part. One of the cool things about using this foam is that you can work it with your hands and form it to make curves. This part took a while to get the curvature just right. Once the lower fuselage was complete, I glued it to the upper fuselage, making sure everything aligned just right. Probably my favorite part of this design are the round cowlings that cover the two motors. They really give the plane a vintage feel, and I think they look cool. The final step was to make the two pontoons. I glued them into place and reinforced them laterally with a couple of popsicle sticks. As soon as I'd finished building the plane, of course the first thing I wanted to do was go out and fly it, so I went to the park near my house. Luckily I had some friends over at the time, and my friend Ryland caught this video footage of the first maiden flight. As you saw from the beginning, this flight didn't go so well. The plane ended up in this tree, and it took us about 10 or 15 minutes to get it down. I'd like to thank my friends Ben and Ryland for climbing up into the tree and helping me get it down. Remarkably, there was actually no damage done to the plane, and I counted myself lucky, and I ended there for the night. The next day happened to be the 4th of July, so I took the plane out to a different field near my house with hopefully fewer trees. Unfortunately, I didn't have my camera with me, otherwise I would have filmed an even more unfortunate crash. What I think happened was the Velcro straps that hold the battery down inside the fuselage came loose, which caused the battery to shift forward into the nose. This caused the plane to do a complete nosedive right into the ground. When I first looked at the plane, I noticed that there was some damage on the nose and one of the motor mounts had come unglued. Upon further inspection, I noticed that one of the wings had broken in half, including the spar that runs the entire distance of the wing. This was a little harder to swallow because I knew that the repairs would be more extensive. I wanted to share this video with you because I wanted to show that it's okay to fail, and that's how you learn things. I plan on repairing the plane, and hopefully I'll make a video of that. On a related note, recently I found a model air park near my house. This past Saturday they had an event where people brought their war-themed planes, and it was a day of flying and it was a lot of fun to watch. There were even some jets that were pretty cool to watch. I was able to do lots of filming that day, so stay tuned for a video of that event. If you enjoyed this video, I'd like to ask you to consider subscribing. I make lots of videos about electronics, aviation, and engineering in general. Thanks for watching.